APIs are the primary gateway for data exchange between microservices, mobile apps, and the public internet. Because they expose the internal logic of your software directly to the world, they have become the most targeted vulnerability surface in the modern stack. The OWASP Top 10 for APIs is dominated by authorization failures and data exposure. Attackers are no longer just trying to bypass a firewall. They are sending legitimate-looking requests to endpoints that lack proper object-level checks, essentially asking the API to hand over sensitive data voluntarily. Most organizations now report security incidents in their production environments. Traditional defenses often fail here because they weren't designed to parse complex JSON structures or track how a single user interacts with dozens of different microservices over time. Because an API is a direct door to your business logic, securing it is a baseline requirement for any production-grade application. This risk has created a massive market for security tools. But for an engineering lead, having 15 different essential products to choose from often leads to total paralysis. Buying all 15 tools at once or looking for a single silver bullet platform is a recipe for budget waste and configuration debt. You end up with overlapping rules that add latency and generate a constant stream of low-value alerts. Effective security requires a strategy of 4 distinct layers: traffic control, identity, threat detection, and proactive testing. You only implement each layer as your traffic and risk profile demand it. The real challenge isn't finding the best tool in a vacuum, it's balancing your available budget against the operational overhead your team can actually manage at their current stage. We start at the perimeter with API gateways. Tools like Kong or Nginx function as the primary point of entry, routing requests and enforcing global policies before they reach your internal services. At this layer, you enforce rate limiting and IP filtering. Blocking malicious ranges protects the backend. These static rules filter out automated attacks, stopping roughly 80% of unsophisticated threats. However, they cannot stop an attacker using valid credentials for low and slow business logic abuse. A gateway is a mandatory first line of defense, but relying on it as your only security measure creates a gateway illusion. It keeps the door locked, but ignores what happens once someone is inside. Layer 2 addresses the critical identity gap. Modern APIs must move beyond static API keys, which are easily leaked and provide no way to track individual user actions. This requires an identity provider like Auth0, Okta, or Keycloak. These tools manage user authentication via OAuth 2.0 and issue short-lived JSON web tokens for every session. This shift provides precise user-level attribution. Knowing exactly who is making every request mitigates broken authentication. Managed providers save engineering time, but carry subscription fees. Self-hosted options remove licensing costs, but require your team to manage infrastructure and patches. Validating the connection itself is just networking. Validating the identity behind the connection is the actual perimeter of a modern API. The most dangerous attacks use valid credentials to abuse business flows. Because the traffic looks legitimate, static gateways and identity checks will not flag them. Layer 3 uses advanced threat detection from platforms like Salt Security or Cloudflare. These systems move past rules and use behavioral analysis to find anomalies. You feed your API traffic into machine learning models to establish a behavioral baseline. The system learns the normal pattern of how your endpoints are consumed. This catches sophisticated data exfiltration. If a user suddenly changes their download pattern at 3 a.m., the system detects the anomaly and blocks it. These platforms require a learning period, which may generate false positives as models adjust, requiring manual tuning. Behavioral detection is the only defense against attackers who have already cleared your authentication hurdles. The 4th layer is security testing, often called shifting left. The goal is to find vulnerabilities during the development cycle, rather than discovering them after a production breach. This involves integrating dynamic testing tools directly into your CI and CD pipeline. The scanner probes your endpoints on every pull request. If it finds a vulnerability, it rejects the code, forcing a fix. This automated scanning slows deployment and requires triage discipline, but catching an error early is significantly cheaper than remediating a live vulnerability. Proactive testing creates development friction, but it ensures that security is a built-in part of the process, rather than a costly afterthought. To avoid over-engineering, use the API security maturity model to decide which layers you actually need right now. Level 1 teams should focus on foundational, low-cost tools. Use Kong for basic routing and rate limiting, and use Keycloak if you have the engineering time to manage your own identity service. At Level 2, developer time is expensive. Pay for managed services like Auth0 for identity, while adding free testing with OWASP API. By Level 3, with complex data, standardize on Okta for access and Burp Suite for penetration testing. Security must evolve linearly. Skipping the foundations of identity and traffic control to buy an advanced testing tool will still leave you exposed to basic authentication attacks. Level 4 is for enterprises in highly regulated sectors. These organizations must move beyond rules-based security and deploy behavioral detection like SALT or Cloudflare API Shield to catch targeted identity-based threats. A gateway is one locked door, but a complex API has thousands of windows. Secure only the front door and you miss the leak. Engineering leadership must balance the financial cost of managed tools against the significant operational overhead of maintaining open-source alternatives. Audit your current architecture today. Identify your maturity level, find the missing layer in your defense in depth, and deploy the tool that matches your current scale. Effective API security is a process of continuous layering. You start with the foundations of identity and traffic control, and you add advanced behavioral tools only as your traffic and risk profile justify the complexity.